So today we're going to look at scatter plots and looking how to graph what we call piecewise functions. We'll start with the scatter plots. It involves using your calculator, so make sure you've got that out. All right. The problem asks us to use a calculator to find a linear model for the average total math SAT score using the table value over to the left. Now, as you can see in this table, all your total math scores are right on the right-hand side of that table, so they all exist right here. What we're going to do is we're going to put all these values into the calculator, and we're going to use them to do a scatter plot and then draw what we call a best fit line or a least squares line that best describes that data, and we're going to find an equation for that. And using that equation, we're going to find the predicted value of the total math SAT score in 2020. All right, so again, let's go to our calculator. You're going to need to know what these numbers are in the total value for each year. So make sure when we get there, you rewind the tape or the video and copy these onto your calculator. So now we're going to go to the calculator. So here we are on our calculator, and the first thing we're going to do is we're going to put that data into the table. So in order to do that, we're going to hit this button that says Stat, and this takes us to this new screen, and what we're going to do is hit Edit, which is number 1. Now you're going to take the data in that table. Again, you're going to have to rewind the video a little bit to see that data and plug it into L1 and L2 of your calculator. So do that now. Once we've done that, we're going to use our calculator to actually see what this graph looks like. Now, in order to do that, we have to, first of all, get our calculator to say, hey, I want to plot these points. So in order to do that, we're going to go to our stat plot button. And if you look, you have to hit second followed by y equals to get to stat plot. Our stat plot now is turned off. We're going to hit 1 and turn our stat plot on by hitting enter here. We're going to do a scatter plot, which is something over here. Once we've done this, it says take all my x values from L1 and take all my y values from L2 and give it this little mark. So we'll go ahead and do that, but in order to actually make that happen, we're going to have to graph this in the appropriate window. So let's look at our window right now, and my window is very small. Our x values on this are our years, and we knew our years went from 1972 all the way to 2000 and something. So I'm going to start at 1970 for my x values, and then my y values I'm going to go, I'll just go to 2020 for the heck of it. And the scale really doesn't matter. I usually pick 1. For the y values, we were varying, I don't know, somewhere between, the 500s and the 400s. So let's just go ahead and look at our table one more time. We notice we went from 520, which was our high, to 490, which was our low. So I'm going to start my y values at, let's say, 470, just to make sure I have them all in there. And I'm going to go to, let's say 540. So that will enable me to see everything in my picture. Then I'm going to go ahead and graph. If you look at the graph, here is a scatter plot of those table values. The next thing we want to do is we want to draw a best fit line, or what we call a least squares line, for this data, a data that best approximates, or a line that best approximates those data points. So in order to do that, again, we're going to quit this screen, so we'll go second quit, and we're going to hit stat one more time. And this time we're going to move over to the calculate portion of this. And if you notice down on number 4 right here, it says linreg, or linear regression. That's the choice we're going to pick. Now what this will do is it'll take my L1 and L2 values and calculate the equation of a line. So there's my equation of the line, where y equals ax plus b, a is 0.62 whatever, and b is -743. Next, we'll ask our calculator to take and graph this actual line. In order to do that, we hit y equals. And what I want to do now, I have something in here, so I'm going to clear that out, is I'm going to tell my calculator to put that exact equation in y equals. So to do that, I'm going to hit this bars button right here. I'm going to go down to statistics, which is number 5, and hit that. And then I'm going to move over to equation. And you'll notice reg equation pops up, and I'm going to use that button. So what it's done is it's plugged that exact equation into y equals, and I'm going to go ahead and calculate that. So here's an actual graph of the best fit line, or what we call our least squares line. Now, the next thing our problem asks us to do, if we look at it, is it asked us to take and use that model to predict the score in 2020. So going back to our calculator, we want to know what the y value is at 2020 on this line. We can do it a couple of different ways. My favorite way is using our table. So the first thing I'm going to do is I'm going to take and tell my table I want it to actually find a specific answer for us. So what I just did was I hit second and window, which is table set, and I'm going to take and tell the calculator to say, let me choose an x value and you give me the y value. So to do that, I go over to independent, hit ask, and then I'm going to go back to my table. I'm going to hit second and graph, which goes to the table, and notice I have a blank screen. And what it does is it will take and allow me to input a number, in this case 2020, and all I have to do is hit enter, and it tells me my y value, or my predicted SAT score, is 524.31. So going to solve this whole guy, we found out our answer for B is about 521. And if we want our answer for part A, what was that least squares line? I believe it was 0.62x minus, well, let's go find it. Minus, let's go back to our window. And it's not there anymore. I think it was minus, let's say, I think it was 743 point something. All right, so that would be the two equations for this least squares line and the predicted value. Now we're going to move on a little bit, and we're going to do some graphing. Standard graphing, which we know about. So let's say I want to graph y equals 2. If I want to graph y equals 2, I draw an XY chart, and y equals 2 would be somewhere, let's change our color here, somewhere up here. All right, and we're going to add a little piece of what's going on. So I want to only graph y equals 2 when x is greater than 5. So basically, I want to start right here and just graph this line in the rightward direction. We'll do that in green. So the green line is really all I want to graph. So consequently, I need to get rid of all this other stuff, like so. So the green line would be the graph of y equals 2 when x is greater than 5. Makes sense. Let's take that a step further. Piecewise functions are a set of functions combined together over different intervals. Again, we're going to take and draw an XY graph. And over on the left, we have what a piecewise function looks like. it asks me to graph a bunch of horizontal lines, y equals 3, y equals -5, and y equals 2, during these intervals. So the first interval says, we'll graph this when x is less than 4, actually less than or equal to. So let's say here's my x value of 4, and I want to graph y equals 3. Well, that's a closed dot because it equals, and a line going to the left. Then it says, well, I'd love to know what y equals -5 looks like, but I only want to see that between 4 and 6. But notice in this case, the 6 and the 4 are not included in my y values. So I have to open circle these guys and then connect the dots. And those are everywhere that y is equal to 5 between 4 and 6. Then I want to see y equals 2 when x is greater than or equal to 6. So in this case, x can equal 6. And I now have another horizontal line. That's the most basic piecewise you're going to get when you have these horizontal lines. Let's move to the next example. Now in this case, we have some lines with slope in it, and again another horizontal line. So I'm going to take, again, draw an x and a y axis. And I also want to take and find out what y equals 2x plus 5 looks like when x is less than 1. Well, where is 1? Let's call 1 right here. Now I can do this a couple of different ways. Some people like to just use slope intercept, go up to 5 and then go up to over 1 and then put a dot there. Not my favorite way, because sometimes you don't land on the spot you want to land at. In this case you would, but what I like doing is finding my exact y value when x is equal to 1. Well, to do that, I just basically find this function's value at 1. So if I were to plug that in, I get 2 times 1 plus 5, which equals 7. So at 1, I get a value of 7. However, I do have one issue. Since x is less than 1, I have to open circle this point. Now I also know this has a y-intercept, like I said before, of 5. So I can basically use those 2 points to make my line. Now between 1 and 3, let's call this 3, I have a y value equivalent to 1. Again, in each of these cases, 1 and 3 are included for x, so I can fill those dots in and then connect the 2 dots. In my last case, I need to find out what the line of -x plus 6 looks like when x is greater than 3. So again, I want to find out the y value when x equals 3. So I simply plug 3 in. It's -3 plus 6, which equals 3. So again, I go up to 3 and 3, and I'm going to put an open circle at 3, 3. Then I'm going to take and do a slope of -1. So I go down 1 over 1, put a dot, and draw a line. So there's that piecewise graph. Let's move to the next level of difficulty. Now I have 2 linear equations. I don't know if this is any more difficult or not, because all we're doing now is graphing 2 equations. So here's my xy axis once again. And I need to graph these 2 equations when x is less than 6 and when x is greater than 6. So just like last time, I need to know what the y value is when x is equal to 6 in my top equation and my bottom equation. So in order to do that, I'm going to plug 6 in. So I take and find function's value at 6. So essentially I have 2/3 times 6, and I'm going to add 4 to that. 2/3 times 6 is going to get me 4, plus 4 is 8. So I have a point at 6, 8. And that's not included, so I'm going to open circle that. This says I have a slope of 2/3. Now I can't go up 2 and over 3 because the stipulation of this equation says I have to graph when x is less than 6. So to get a positive slope and not go up and over, I have to go down and to the left. So I'm going to go down 2 and over 3. So let's say down 2 and over 3, giving me an equation that looks something like that. All right, and we know this would go through the point 4 because that's its y-intercept. Next, I have to find out the value of -1/2 x plus 5 when x is equal to 6. So again, I'm going to take f of 6 in this case, which is -1/2 times 6 plus 5. -1/2 times 6 is -3 plus 5 is +2. So at 2, I get to put a closed circle this time because 6 is included, and now I can do a slope of down 1 and over 2. Connect the dots, and there's my piecewise function. Next level of difficulty is done, basically. So what I want you to do is I want you to take and answer these 2 questions on the form, and we'll get back to you tomorrow.